everybody, welcome to our third algebra flip video, and today we are going to be solving equations. This is a skill that we assume most of you already have, but we want to refresh your memory on this. I want to remind you with the flipped videos that when we ask you to pause, we expect you to pause your device and actually do the problem, and then we'll go over the problem and you can do that too. I am going to be giving you 4 sample problems. I want all of those problems in your notes. The only part of solving equations that I'm going to be talking to you about is addition and subtraction. I want to start out by reminding you about solving equations. Solving equations is keeping equations in balance. And if you remember your science classes where you actually worked with balance, the balance pans and weights on the balance pans, reminder how you always had to keep the same weight on both pans in order to keep them balanced. Likewise in equation, if we have our equal sign where your fulcrum is and we need to balance that, for example, say we have a 1 pound weight and a 4 pound weight on this side, in order to keep that balance, obviously you need a 1 pound and a 4 pound weight on the other side. If you remove one of the weights, if you remove the 1 pound weight from one side, we now have an unbalanced type of scale, like an unbalanced equation. We need to remove the 1 from the other side to keep the equation in balance. The second thing I want to remind you about is our ultimate goal is always to get x by itself, to isolate the x. So let's start with our equations. And my very first equation that I would like you to write in your notes, equation number 1 is x plus 2 equals 5. I mean, this should be a very simple equation for you guys. We're trying to isolate the variable. Sorry you guys, I'm writing in red. We're trying to isolate the variable, so I'll ask you, what do we need to get rid of if we want x by itself? We need to get rid of the 2, so to speak. If the 2 is being added, we do the opposite or inverse operation. We subtract, you might say add negative 2. I usually say subtract 2 from both sides. Whatever we do to one side, we must also do to the other side. There's your first example, x would equal 3. Now I would like you to try one. I would like you to try also x plus 2, but let's have it equal to negative 5. So at this point, I want you to pause and do this problem. Okay, welcome back. I'm going to solve this equation for you. I'm going to say you are now adding 2 to the x. You want to isolate that x. In order to isolate that x, we're going to do the inverse operation. We're going to subtract 2. If we subtract 2 from one side, we must also subtract it from the other side. We've isolated our x. That's what you did in your notebooks. Reminder, negative 5 minus 2. If you need to think of it when there's 2 negatives as negative 5 plus negative 2, that's fine. Again, this is problem number 2. Okay? All right, I'm going to continue on. I'm going to continue on with that to problem number 3. Problem number 3 is stated x minus 2 is equal to 6. I'd like you to write this in your notes, talk to you about it a little bit. Again, isolating the variable. So 2 is being subtracted from 6. We do the opposite or inverse operation. We add 2. Whatever you do to one side, you must also do to the other side. I'm pretty sure this is all much review for you guys. Okay? Now I'm going to have you try one of those. I'm going to have you try number 4. X minus 2 is equal to negative 6. Go ahead and try that. So I need you to pause your device. Try this problem. Welcome back. I assume you tried this already. We need to get x by itself. We need to remove the minusing 2. We're going to do the opposite or inverse operation. We're going to add 2. Whatever we do to one side, we must also do to the other side. We isolated the x. Negative 6 plus 2 is negative 4. That is one-step addition and subtraction. We're now moving into one-step multiplication and division with Mrs. Halpern.
Hey everybody, I hope you understand what Mrs. Brenner just did. I'm sure you do. Hopefully this is all stuff that's coming back to you. In fact, it was kind of interesting in class on Friday. We did a little inverse operation problem with that 4x plus 3, and some kid said, I don't know how to do this, I don't know how to do this, and he wrote it down. He's like, oh wow, I forgot about this stuff. So you guys know it. You will remember it as long as you see it. So let's go on. We're going to do problem number 5 right now. Problem number 5 is 2x equals negative 16. Now we remember when we have a number next to a variable, that means to multiply. So what we want to do is we want to undo multiplication. Because again, like Mrs. Brenner said, we want to isolate x. So in order to isolate x and to undo multiplication, I have to divide. When I divide, I'm going to divide this side by 2. Again, the balance, whatever you do to one side, you have to do to the other. So I'm going to divide both sides by 2. Now think about this, you guys. 2 divided by 2 is 1. 1 times x is x. So now we're left with x. And so we have x equals, and 16 divided by 2 is negative 8. And then we know that 2 times negative 8 is negative 16. So that works. So now I'm going to have you guys try one. Problem number 6. Let's write that down. The problem is negative 8x equals negative 56. So now what I'd like you to do is I'd like you to pause your device right now and try this problem. Okay, welcome back. Hopefully all of you recognize that this is a multiplication problem. Negative 8 times what number gives you negative 56? Now most of us can eyeball that and know the answer. However, we're going to be having a lot bigger problems like this, so we need to do this systematically. So what we're going to do is we're going to undo multiplication again by division. Now notice we do not do the opposite. Like in adding, you subtract and it's a different number. This is the same number. If I multiplied with a negative 8, I have to divide both sides with a negative 8. Negative 8 divided by negative 8, again, is 1. 1 times x is x. And negative 56 divided by 8 is positive 7. So hopefully you guys were able to get that problem. Now the next problems that we're going to look at, same idea, except it looks a little bit different. Write down problem number 7. We have x divided by 5 equals 6. Lots of times kids freak out on these problems and they go, oh, it's a fraction, it's a fraction. It's a division problem. How do you undo division? You undo division by multiplying. So if I say I want to multiply both sides, I'm going to multiply both sides by the number with x. I'm going to multiply both sides by 5. Once again, if you think about this, 5 times x divided by 5 leaves me with x, and 6 times 5 is 30. So our answer to this problem is 30. Now I would like you guys to try number 8. Number 8 is x divided by negative 2 equals positive 10. So please, right now, pause your device and try this problem. Hopefully all of you recognized if I take x and divide it by 2 to undo division, I multiply. I multiply both sides by negative 2, not positive 2. Multiply this side by negative 2. Once again, 2 times x divided by 2 gives you 1. There's your x. 10 times negative 2 is negative 20. And that would be done with one-step problems. Mrs. Brenner did adding, subtracting. I did multiplying, dividing. Now Mrs. Conway's going to come in and tell you what happens when you put those two ideas together.
Now that you're the experts on the one-step problems, it's two-step time. Two-step time, I'm going to have you first jot down an example and we're going to go from there. I'm going to tell you what it looks like. Right, this problem, we're going to start with 4x plus 7 equals 19. This time it has multiplying and addition, so it has more than just one operation in it. Again, this is problem number 9. I need a little help with the numbering, just keep me going with that. Since we have two operations, multiplying and addition, now we have to talk about what's our goal. Remember, we want to get that variable x all by itself. We want to isolate x. Where is x? Find it. Look, there it is. I see it with the 4. I like to circle it. I want to get that by itself. Now I have this adding 7. Remember what Mrs. Brenner talked about when you had to add 7? What can I do to undo the adding? How to undo adding 7? If we subtract 7, now that 0, it adds to 0. You do the same thing on both sides, just like we've been doing. Bring that equal sign down. Always carry that with it as you go. And now this 7 and negative 7 or minus 7 zero out. And what's left is 4 4x, it's multiplication. 19 minus 7 is 12. And now we're back to, now we have one operation, multiplication. How do you undo multiplying by 4? Like Mrs. Heller talked about, divide both sides by that number with x. 4 divided by 4 gives us the 1x. It's okay if you put a 1 in there. Equals 12 divided by 4, x equals 3. You can write it that way, you can put the 1, you don't have to. You try this one, number 10. Negative 3x minus 5 equals 10. I'd like you to pause your device and try that problem. See what you can do with that problem. Good. Let's take a look and see how you did. Where is x? I want to isolate x. Right now it's with that negative 3. The operation I have here is minus. How do I undo minus 5? And the inverse of subtracting 5 is to add 5. So you have a negative and a positive, so it zeroes itself out. But if you do it on one side, do it on the other. Again, keep that equal sign coming down. 5 and minus 5 is 0. Bring down to 3x. 10 plus 5 is 15. And make sure you bring that negative sign with it. Copy, like I always want you to copy correctly. Now we have multiplication. How do we undo multiplication? We divide by that number. And remember what Mrs. Heller said? If it's negative, you divide by a negative on both sides. Negative divided by negative, 3 divided by 3 gives you that 1x, is what we're looking for. 15 divided by negative 3, negative 5. Awesome. The next one is problem number 11. This one looks a little different. X over negative 2 minus 6 equals negative 11. This again is a two-step. It has division with it, with that fraction and subtraction. So again, look where the x is. Again, make sure you're copying this down. Look where x is. Get rid of that red. And that's what you want to isolate. And how do we undo the minus 6? We're going to add 6 to both sides. You do it to one side, do it to the other. That zeroes out and bring down what's left. X divided by negative 2 equals negative 5. Again, our ultimate goal is to isolate that variable x. Right now it's division. How do you undo dividing negative 2? You're going to multiply both sides by negative 2. Again, that negative 2 times x divided by negative 2 is going to give you a 1x equals negative times negative, 5 times 2, positive 10. I'd like you to copy this one down, and I'm going to have you try this one. N over 4 plus 7 equals 2. I'd like you to pause your machine, pause, and work that problem. Got it? Well done. Where's the variable? The n divided by 4, we're going to undo that operation that's not with the variable, the plus 7. How do you undo addition? You do it to one side, subtract 7. On the other side, bring the equal sign down. N divided by 4 equals negative 5. Now you have division. The inverse of how to undo division is to multiply by 4 on both sides. And we get a 1n. Negative 5 times 4 is negative 20. And if I make an error up here, you make sure you tell me in class tomorrow if there was an error in that problem. I have one more problem for you to try. And just be careful with this one. It's not a hard problem. 2n minus 8 equals negative 8. Jot that one down. I'd like you to pause your machine and do that problem. Good. Same thing, two-step problem. Here's where the variable is that you're going to isolate. How to undo minus 8. We're going to add 8. Remember, do it to both sides. 8 minus 8, that's zeros. We get 2n equals, 8 plus negative 8. That's 0 there. Oh, okay. How do I undo? Keep going. How do you undo multiplication? Divide both sides by that number with n. We get 2 divided by 2, which is 1. And what is 0 divided by 2?
2.
2. Sure about that? Try that again. 0.
Oh.
Tricky, you can have 0 for an answer. 0 is a number, that can be an answer with a two-step problem. Mrs.
I'd like to
Brenner?
add one thing.
Here comes Mrs. Brenner, welcome.
You know, I like to be in movies, so. I would just like to add one thing. I know all of this seems simple, really simple to you guys, and we don't mean to insult your intelligence. And we know that you could look at a lot of those problems and just tell us what the answer is by looking at it. But we're really, really strict about, we need to see work, we need to see your steps. Trust us on this. The problems get way more difficult, way more complicated, and we want you to have your practice of doing them correctly already established so that you can do the more difficult ones. So we expect to see every step. If we see you do something to one side, we need to see you also do it to the other side. We have to see that or we won't give full credit. So please remember to do that. We need to see all, what were there, 10, 12 problems, all the problems copied down in your notes. That'll be how you get your points for tomorrow. 13 problems? Okay, thank you.
All right, one last thing. What we think is really cool about problems like this, take a look at this one. Remember when Mrs. Conway said, you guys can tell me if I did that one wrong? Well, Mrs. Conway could have checked right away to see if this was the right answer. Most of you probably know how to do that. But if we say n is negative 20, then let's replace n with negative 20 and check. Negative 20 divided by 4 is what? Negative 5. Negative 5 plus 7 is what? 2. So we can say both sides balance. 2 balances 2. It checks. Therefore, I know that that's the right answer. Even with this problem with 0, you guys, take a look at the problem with 0. You would think maybe that you did it wrong. Whoop, let me. And a lot of kids want to say no solution. No solution. 0 is a number. Let's check it. 2 times 0 is what? 0. 0 minus 8 is what? Negative 8. Negative 8 balances negative 8. So it works. So good luck. We're going to probably catch you with a warm-up tomorrow to see what you can do on problems like this. And we're going to check to make sure you have everything in your notebook. Have a great evening.
Bye.